Hey there everyone, my name is Hitesh and I make coding related videos. And in this video, we are starting a really long journey to build our own AI powered SaaS application. Yes, you heard it right, we are building a SaaS which is all powered by AI. Now, first and foremost, you need to understand that there is already a product known as ChatGPT and Gemini and so many other. They all are really good models and nobody can actually compete with them that easily. But why do people actually pay for these chat models? Simply because they are very generic and they do the stuff. But there is also another case of that. People pay for these generic stuff, but people prefer to pay for a specialized stuff and people easily pay for that. And that's the foundation of any SaaS business. You solve a particular problem. For example, the cursor is really specialized in helping you to write code, and that's why people pay to cursor. There are some applications and websites which helps you to make presentation or they helps you to get information from your Excel sheet. People pay for that because that solves a pain point. And that's exactly what we'll be doing in this application. This is not a generic chat application. This is powered and specialized to help you to create content. Yep, that's where it shines. Now, easily, this entire application can be modified for so many things. Maybe you want to make it another application which go ahead and read the documentation from any web page and help you to build applications. There are possibilities that can do magic in this one. But where we are specializing is how an application can generate content for you, content specifically for LinkedIn posting, or maybe content specifically for creating YouTube videos, a whole planner for making YouTube reels or Instagram reels. This is what we are exactly building up. So let me walk you through first that what this application is. And yes, I have improved myself a lot. Now we focus a lot on the demo of the application. So here goes the demo. Let me take you onto the screen and walk you through with this. First of all, what is this project and the overview? Once we read the overview, then we are going to go ahead and work on that. So this is the overview. So this is essentially a sophisticated AI-powered chat platform that can help users with content creation. Not only just content creation, it does research for you. It does real-time collaboration for you. And it make it particularly useful for writers, content creators, and teams that need AI assistant in their communication. And these are not cut off from any kind of a date. It can actually go ahead, go onto the web, search for any modern and updated data and any event that has happened, and can also bring that data in the research itself. So time for a demo, of course. Let me walk you through with this application. So this is how the application looks like. And I have specifically not focused on the authentication because authentication can easily be managed by Clerk or any other application. You can build your own these authentication. I have focused a lot on them in the previous part. We have a lot of videos on that. Now here you can just go ahead and enter your username. So I'll just go ahead and say Chai Code. Feel free to give it any username. I'll show you one more username as well, which will help you to understand the power of this application. As soon as you start chatting, this is how it goes ahead and work with this. So notice here, it's a new writing session. And if I just move it a little bit here so that you can see the entire application, I'll minimize my Postman. Don't need that as of now. So notice here, we don't have any writing session. We can click on new writing session here as well. Here we get your AI writing partner. So all of this, we are going to build everything. Now, what would you like to write today? You can write from business, you can write for content, you can write for communication, or you can be just creative. So in the business, write a professional email to my boss about a project. Now, this is not just it. I'll show you more onto that. And we can write the content, write a blog post about emerging trend in my industry, or a communication, write the tone to sound of it, or we can just be creative. So let's go for this. And let's say we want to write something in the content space. What should we do in this one? Or communication, I think creative. I'll just go ahead and because every time you load this, these messages can be changed up. So let's go ahead and ask it that write me an engaging post for LinkedIn that, oh, my bad. Did I mistyped it? Nope, LinkedIn, that tells users about OpenAI open weight models. How interesting that is. Let's go ahead and enter this. And as soon as I click on this, notice here on the left side, I got a session just like the ChatGPT. Now we also get this agent being connected. We can disconnect this and then it will not work obviously. Now we have a deep thinking mode onto this one. This is the latest information. This happened just yesterday as at the time of recording of this video. So this information is not available to any chat agent or anything. So it obviously will go and look and research for this. So notice here, we are thrilled to announce the release and all of this, why this matters and everything. And all of this, it's also available on Amazon, AWS, Bedrock, and all these things. So it has written that, added the tags, and gone all through this. Now, there are so many more things that are happening. Further, we have some of the prompts that we can go ahead and give it. So fix grammar, make it more concise, make it more professional. So all these are based on what kind of response that is coming up. You can just open up these prompts as well that, hey, we have a lot of tones that we can go. Summarize the key point, continue generation, it will do everything. And people pay for this because you are making their life easy. So we need to work with all of this. Now, here's the response that we got up. Maybe you like it, maybe you not like it. You can just go ahead and say that, write it more professionally. So we can just click on this and add this data. And now it will again think for a moment and will start working. It's not any random chat GPT that's going on. It's a really precise one that helps you to curate the content. And there we go. We get much more precise one. And notice here, we also get some links and citation. Everything is all covered in this one. It's not like it's randomly gathering the information. So it's very updated. Now, apart from this, notice here, it says connected. You can disconnect from the agent as well. You can refresh, of course. Now, interesting part, I can just go ahead and say log out. And let's just go ahead and create another username. So this time we'll go ahead and call this as YouTube. We'll start chatting with the YouTube. This is a new session and probably we'll write a professional email about a project update about this chat app that we just finished. I'm just randomly throwing the stuff to show you what more can be done with this one. So obviously now it's thinking again and going with this. Notice here on the left side, we have a session being created. We can of course delete this session as well if you don't like it or you don't want anybody to use it. So we get all the data and everything. You can fulfill that. Now let me go ahead and log this out. By the way, we can switch the theme as well, light theme. I don't like that. I would prefer a black theme, dark theme. Log out, and now I can go back. I can just go ahead and say chai code and start chatting. And there we go. My session was preserved. So we are using memory and so many things. So this is the basic of how this application looks like. Now here comes the interesting part. Let me go ahead and walk you through that what all it takes to build such an application. First and foremost, what it takes is a stream. We are going to use getstream.io to build this application, and this will make our life so much easier. Now, in case you don't know about the Getstream, just quickly look onto the solutions and look at what kind of solutions they provide. You'll be surprised to know that if you click on education, so many education companies, including Harvard Business Studies, they actually use them. And these are very famous companies. So all that I'm showing you is really production grade thing. And best part is in any application or any pricing that you see, they have a really generous free tier plan. So we don't even have to worry. Everything in this application that we have designed is freely accessible and freely available. Now look at the solution. In the social, so many of these apps that I'm pretty sure you have heard about, like Strava, Patreon, and Bunch and all of them, they actually use them day in and day out. Just look at the solutions like Marketplace. A lot of Marketplace actually use them. TaskRabbit, Urban Outfitters, so many of them. So this means this is a well-tested, well-beaten up in the industry, in the market. They have been in here for a really, really long time. Just look at this. Probably gaming. I'm pretty sure you might be aware of some of the gamings companies, or maybe you are more aware of the dating sites. So a lot of dating sites actually use them. So one thing is sure, they are well-tested, well-proven. We will learn how we can use them. If you go into the dashboard, this is how their dashboard looks like. Let me go back onto the home page. This is how the application looks like. This is what we'll be creating. One of the things which you will really like is that you can choose up where your application should, your data should live. This is a really concern for if you're building a SaaS. We'll be choosing Mumbai because that's where nearby to where I live. But you can feel free to choose. They give you so many options. Now, here's an interesting thing. In the chat, you can actually choose the moderation as well. Moderation is really important because people can ask anything to your application, and having that kind of moderation, semantic filter, advanced filter is really, really required. Not only that, this application can be extended to videos and audios and whatnot. Once you learn this basic part, again, the implementation is exactly same. and they give you generous free tier. We'll be working with this one, and so much of this we are going to talk about this because this is the whole basis of this application. And best part, it's kind of free and generously freer. Once you start using it, you will realize that it is actually a lot to test the application and get started with this one. Another thing that we'll be using in this application is this Tavily. I don't know how to say that perfectly. Tavily, this is really nice. Now again, we will be using the free tier of it. So yep, free tiers. Interestingly, if you look at the use cases of this is the most important part. Retrieve trustworthy answers in real time with Tavily search, extract, call APIs. Yep, that's the fun part. Although there are other use cases and businesses of them, but we are not much interested on that. This is what we'll be integrating in our app to work with that. Now coming back onto this, what do we need here and what are we doing? You'll be surprised to see that to build this application, which looks really sophisticated, really basic, just like this, we have a connect, disconnect, but there's so much more going into this app. Just hear me out and you will realize this is not a toy app. This is something that you can put up in your resume. You will be proud of it and you will learn so much. So this is basically an intelligent writing assistant chat app that combines real-time chat app powered by Getstream, of course. For seamless messaging, we will be using AI writing assistant. We will be using OpenAI GPT as well. You can use any other model as well. It's not going to be that much of the dependency on that. You can use Gemini. You can switch any model. We will keep it that really friendly. We will be using web search and we'll be using the modern UI. Most of our UI will be on the shared CN, but I'll walk you through with the easiness. Now for the front end, we are using React with TypeScript to make it really professional. We will be using Stream Chat React components. We will be using Tailwind CSS with shared CN, of course, for model styling. And we'll be using Vite to build the front end of this application. Now for the backend part, we'll be using Node, Express, TypeScript, Stream Chat, OpenAI, and Tavily. I hope that's how we say it. So this is our full front end and backend stack. Now here are a couple of features and architecture what this application is going through. So first let me go walk you through with that. So architecture, the project consists of two main parts, the backend and the front end. We will learn about the backend with Node.js Assistant, we'll call this. Node and Express, Chat, OpenAI, Telev, and we will learn about the agent management system with automatic cleanup. I'm pretty sure you have never heard about it. So we'll work with that. These are some of our key features. Once we are done with this, I'll walk you through that so much of this is like really returnable in the resume itself. So we will learn about writing prompts, categorizing the prompts for the business content. We'll learn about agent management, dynamic AI agent lifecycle. So yes, every time a session is created, we are creating different agents for that. We are consuming the memories of that. We will learn about the secure authentication, not that much, but still our application is decently secure with JWT tokens. We'll learn about the responsive designs as well. Design is not going to be primary focus, but still we'll design it mobile friendly and everything. Real-time collaboration and web search obviously are the part. Now here is the interesting part. I have divided them into 4 sets of the features that we are going to talk to give you that how complex this application is. First of all, the core server infrastructure. We are using TypeScript so that we have type safety. Even if you don't know TypeScript, that is totally fine. In this course, I'll try to my best to give you that why we are using this type. So in case you are comfortable with JavaScript, you will be comfortable with TypeScript as well. We will learn about the environment configuration, how the secure APIs are being kept in the environment variable files. We will learn about the importance of health check as well. Now, the second part is stream chat integration. This is going to be really, really amazing. Real-time messaging. So in order to handle the real time, what it takes, how does anybody handle the real-time message and communication? We will learn about the user management by dynamic user creation. As soon as you enter the username, we are creating a user at that time. And once you're done with this, we are also deleting that user agent so that we don't pile up with hundreds and thousands of users. We're also working on channel management, so automatic channel joining and messaging. Any other user can also join into this one, same username they can enter and they can enter the channel. We'll also work on the token and all of that. Now this is AI management system. So yes, although this is a product, but this is the core skill that you learn. AI agent lifecycle management. I'm pretty sure you have never heard or worked about this AI agents, that this is the way how it works. Dynamic agent creation, as I mentioned, based on the chat that you're doing, you can actually create and remove these agents. Agent caching. This is one of the production grade stuff. We will be using in-memory caching to prevent the duplicate agents for the same channel. This will help us to reduce our bills. We will also work on automatic cleaning. Although I have chosen 8-hour inactivity threshold for the periodic cleanup, but you can choose 10 minutes, 20 hours, whatever suits to you. We'll also prevent the race condition for the pending agent to prevent the duplication creation. So race condition, it's a pretty interesting one. And then we have the agent platform support, OpenAI integration, extensible architecture, assistant configuration, agent caching, and memory management as well. As you can see, there are so many words that you have never heard about or never seen them. This is what it takes to build a real-world AI application. And of course, we are passing the real-world, real-time messaging as well. This in itself is a skill. So live messaging, AI state indicators, message threading, it looks like a lot. Notice here, it looks like a lot, but it is not that much. Now I'm pretty sure that what looks like a really basic chat app now feels like there is so much in these kinds of application. And that's exactly what I want to mention. What looks really basic and feels like any web developer can do it, no. Your ability to handle these kinds of AI operations and building in AI or Gen AI or agentic AI, it requires more skill than you imagine. And this entire video, or rather a course in itself, is going to give you a great starting point to build SaaS application in the agentic AI world, in the Gen AI world. So welcome to this really, really comprehensive video. This video took really immense amount of effort to build, create, and record, and to edit as well. So my humble request is, please drop a comment in the comment section to appreciate such kind of long videos that are available to you on YouTube itself and other platforms as well. So please, my humble request, drop a comment in the comment section. Just appreciate this. We are keeping a small comment target of just 200 comments. Let's hope so that we can actually finish this or not. That is it for this video. Let's catch up in the next one. All right, there is one very important and very serious thing that we need to talk before we go into this tutorial. A lot of people who watch my videos are coming up from different variety of horizons. Some are absolute beginners, some are getting friendly with the programming, some are trying to build their very first full stack application, very interested in the AI stuff, and some are senior folks. This special whole video is for the senior folks. Yep, people who have built, shipped, and deployed their application, which are being used by at least thousands of users on a regular basis, and they know that how software is complex in the production. This is kind of a glimpse of getting into the production. So if you're an absolute beginner, you will feel very uncomfortable. And I would say this is not for you. You will get overwhelmed. You want me to write every single code and follow along with you and give you tutorial. This is not how things works. And if you want to build any complex software just like this, it requires a team. And I just want to give you a glimpse of how complex things are here. So with this, let me walk you through that what's the difference between these kinds of things and how we actually take on to this one. So there are tutorials which are different type of things. And again, they have different target audience. My target audience for this one is something who is advanced coders. I would say advanced coders. Somebody who knows how complex this is to make a software. Now, if you look at the most popular softwares like ChatGPT or even the T3 chats, it seems simple that, hey, I'll just have a message box, I can select the model and send it, but it is not. It is far from reality. This is an insane amount of, this is an insanely complex software that they have built. And this is not a work of one single developer. This is a work of somebody who has been writing code for decades, probably at least in professional scenario. And then again, not one guy, again, multiple. Let me tell you why this happens and how you can actually work with that. So what happens in these kinds of things that, let's just say this is your server. This is going to be your front end. And then we have another server that is OpenAI or any. Not just OpenAI, let's just call this as generically any LLM. Now look at the complexity that how these softwares are being worked. So first of all, your front end makes a request to the backend. Let's also name them so that it's easier. So this is your front end, maybe in the classic React, maybe Next.js, doesn't really matter. On top of that, this is your backend. It can be in any tech stack, JavaScript, your favorite one, Ruby on Rails, Laravel, whatever you wish. We are going to obviously use the JavaScript ecosystem. Now, as soon as your backend makes a request to the LLM, The LLM doesn't gives you response. This doesn't happens. The LLM doesn't gives you a response directly. Instead, what happens is LLM actually gives you a streaming. These are the data which are continuously generated. So this data reaches to your backend and one by one, and then once this data reaches to your backend, you also have to transfer this to your front end. This already is a complex mechanism that one by one the data is being generated, and how you send this data onto the front end, this is another complex situation. You want to send it every second, you want to overwhelm them by sending every 10 millisecond, or maybe you want to have a little pause and send it every 2 seconds. How do you want to handle this? This is not the only part. How your front end is going to request this data continuously. Either you have to choose an option of stream, continuous polling. There are so many engineering options that can work with that. Now, not only that, what will happen if a user sends a request and your backend is processing this request, but in the meantime, you have sent the same exact request in the same channel again. Maybe you have reloaded the page, maybe you have done something else. So how do you make sure that the same request doesn't get processed again on the backend as well as on the LLM side? Yeah, now you're trying to get how much complex the things are. Not only that, to actually make you understand that how things can be, notice it here that if your application gets a response from the LLM, it's not just the response that you're getting. You need to send some kind of events. Yes, there's a WebSocket actually included here. So you need to send, your backend needs to send some signals onto the front end via the sockets that, hey, my LLM is still generating the response. So either put the message or an icon of typing there so that I know, or the user actually knows that, hey, some more data is coming in. And yeah, this still looks like, okay, it's easy. Let me walk you through that how complex the things are into getting you some real world scenario. So there's a platform that we'll be using, Getstream. But where I want to bring your attention is in the documentation. So if I go into the developer, just look at the chat system, no video, no audio, no activity feed. And this is how the real world applications are being designed. If you look at this, let's look at the SDKs, and I want the SDK of, let's go into the docs, I guess. I am still in the docs. I need the backend client. So let's look into the backend client. Node.js is familiar to all of us. Let's go up here. So inside the Node.js, let me just move this here. Do we have a dark mode for this one? I don't think so, but here it is. Now look at the complex things that can happen. Obviously, you will have a backend, you will initialize the user, you will manage the user, maybe your authentication is there, not there. So this much whole thing is there. Now, your app setting, it's okay, no problem there. And user permission, now the channel. Now, if you look at this, anytime any chat application is created, there are multiple channels on the left-hand side that you see. Each channel has a different context and different conversation that's going on. If there is any error message that needs to be updated within that channel itself, not any other channel. So you need to receive your channel ID. You need to handle your message ID. That's the basic of it. And this is where they mention creating the channel, watching the channel, updating the channel, querying the channel, capabilities, all the channel pagination. Yep, this is what happens in each of the channel that you see in the chat GPT, T3 chat, whatever you are using. Muting, hiding, who are the members of the channel? Is the channel shareable? Yeah, that's that kind of a complex stuff. Now, message is not just the message, because for you, it looks like, hey, there's an LLM that we are sending the response and going with that. But what happens if you have designed some kind of a tool? LLM is nothing without the tools, and also known as agents. So there could be different agents in the tool set. Maybe there is a search agent. Maybe there is a GitHub agent. Maybe there is a database agent, so, or agents or tool. These are your custom code written in some language, and your LLM sometimes, while sending the response, holds up everything that, hey, maybe this is the packet that needs to go up. Just after this packet, they says, hey, I need to call the tool. So they're going to call the tool. And in the meantime, you also have to send a signal to the front end that, hey, I am doing some tool work, so you need to wait there. So there's a signal that goes up there. And then tool may take some amount of time, and then tool sends the response to the LLM, not to us. And then after processing that, you have to send the response to the backend, and then some signals, and then to this. I hope now you're getting how complex things can be. It looks really all rainbows and sunshine when somebody just walks you through with an 8 hour of video and say, hey, it's all done. But this is how what happens in the reality. Oh, I forgot that what happens in the file upload. When you upload the file, your server needs to process this file, and you have to look for all the security issues in the file and then have to send it to the LLM as well. Look at this. Yeah, a lot of polls and all these things happen. Then we have the moderation as well. And then we have all the events as well. Webhooks. We have the pushing of the webhooks. We have multiple events. We have SQS, SNS. Yeah, you need a queuing system because user might be calling the agents back to back or might be sending the request back to back. You need to handle that. And this is how I really appreciate the Getstream, that how complex their documentation is, which is required to build a production grade application. And then they have all the rate limiting, you have all the debugging issues, how it goes. And then they also mention all these best practices, which is rare to find, that how do you integrate all these things. Just to give you an idea that, yeah, this is not going to be a toy app. This is not going to be an application. And we are not going to handle each and every edge case scenario that is possibly there in this app, but I will walk you through that what can more happen with these kinds of methods if we don't handle them or if we handle them. So coming on to the point that now you understand the complexity of this entire video that I'm going to come up for you. Just please understand this is for the advanced user. A lot of code we are going to write where it is required for me to give you enough time to absorb the code. I will write the code there with you, but a lot of piece of the code is going to be code walkthrough. And again, the code files will be given to you on the GitHub. And I would say this is not still production ready. You need to handle so many more cases for that. So this is going to be a great starter point if you want to build any application which is similar to ChatGPT, T3 Chat, or any other wrapper that you're building. It's not easy, but it's the good part. This is where you learn. When you get uncomfortable, you learn more. That is it. That's especially I wanted to make this section so that you understand the target audience for this video. Let's go ahead and start the video now. All right, so let's go ahead and get started with the application that I just showed you and how we're going to build this. We're going to keep things separated. So we will have a separate backend and a separate front end. And for this, let's set up the backend first. This is the part where we are moving. We can obviously move in the front end as well, but it doesn't make sense because most of the logic and the things that needs to happen happens on the backend, and then we provide an interface. Of course, I'm not shorting this one down. This has its own complexity, but this is where the application brain starts. So we're going to start from there as well. I do have a folder, and let's do one thing. Let's keep two separate folder, one for backend and one for the front end. So within this one, let's create the same thing in the same folder itself. And later on, you can decide to upload this onto a separate URL, separate hosting, or can do it all at once. Depends on you how you want to execute this. So let's call this one as streaming. So we are building a chat app. So let's call this one as stream chat. Stream chat backend. And I know this is a really long name, but you should keep all lowercase without spaces. This is how things actually work. Right click, open the integrated terminal so that we are on the folder, not on this one, but if I just go ahead and pwd present working directory, notice this that I'm already inside this backend folder where I should be. And from here, I'm going to go ahead and say init-y so that it just gives a yes to everything. And we're going to change this package.json folder a bit. So let's open this up. How does it look? Pretty decent, I would say, the way how we want to start it. Couple of things we are going to change. First of all is this index.js. This will be inside the dist and slash. The reason for that is we will have eventually a distribution folder which is responsible for serving our entire application. Although we don't need to write this now, but still I'll just add this. There are two, what you can choose is common JS and module. We will choose module. It's not going to be much dependent because anyways we are writing JavaScript, but that's okay. We can keep it this way or we can remove it, just totally up to you. Then another thing is engine. Engine is where you define that what kind of Node.js version you're using. So the version that we are using is anything above 20. That's going to be fine for us. And then we will have a few script as well. We will install a few utilities as well. First, let's go ahead and install them. This one is fine. Author license is good. Let's go ahead and install a few applications, and I want you to focus on the version in itself. So first of all is going to be npm install Axios. So let's go ahead because we obviously want to make a few web requests. 1.11 is absolutely fine. Anything in the range of version 1. We'll be needing course as well. Course is the library which helps us to serve our application to the front end as well. So course 2.8, good enough. We also will need to keep some of our things hidden from the general public. So we will need .env. That's great. And anything in the range of 17 is good enough. 16, I don't think so. There's hardly much of the changes here. All right. Now let's go ahead and install Express. Now in the Express, we do have the latest version of 5 as well. But if you want to put this into production, right now 5 is kind of a new, I don't trust it that much. Yet the reliable version is version 4. I have built this application in the version 4. Whatever is the latest version of 4, go ahead and use that. I'll use the version 4 just like that. If you want to use just like this, it will install the version 5, which is, as the time of this recording, it's very new. So just by adding @4, your code will work just like mine is working. So we'll just use the Express, whatever is the latest version of Express is. 4.21, definitely fine. And we will need to talk with OpenAI as well. So let's go ahead and say, hey, OpenAI, let's go ahead and talk to you. And then last but not the least, the most important component of this entire application is going to be the stream chat. So let's go ahead and install that. And for the stream chat, they might obviously upgrade the version in the future. I don't know. So just write @8, whatever is the latest AI version on the 8. Yes, it's being a very long time running application. So we just don't want any breaking changes to happen. So anything above or in latest in the version 8 is good enough for us. So this is our dependency that we want to work on. Now we do have some of the dev dependency as well. So let's just say npm install and -d to install the dev dependencies. First of all, we want to install types because we will be working with the TypeScript. So anything that course has to offer as the type, we will get that. We will also get all the types for the Express as well. So just go ahead and say types of Express. And then we will need nodemon so that everything runs on its own. We'll be having a prettier as well. And of course, we will have TypeScript as well. So go ahead and install all these dev dependencies. There we go. Everything looks okay. Nothing, no breaking changes. In this one, any latest version is fine. So I'm not worried about version that much. But notice here, this has installed the version of 5 for us. The types of version 5, I am working on the version 4. So I would prefer the types also to be version 4 itself. So let's go ahead and remove this. Go up here and we'll say @4. And hopefully this is going to change that. There we go. Nice and easy. If you're working on version 5, Express don't introduce those breaking changes that much. So that's okay. Now, once you're done with this, now we want to have the TypeScript. So that's why we have installed this. We will come back onto this because we have to modify a few scripts. But before that, we will create a new file into this to introduce our TypeScript configuration. So all we have to do is tsconfig.json. And these are coming up from my old project. So if you have any old project, these are the files or these are the settings that actually comes from all the way along. Every one of my project has this or kind of a similar kind of a thing. Now, another thing that you'll see that in the module, we are using CommonJS, and I want you to focus on this one. We will be using CommonJS. So these are the settings that I've done. Now, anyways, what happens is whenever you work with the TypeScript actually doesn't run. So if you have any TS, just like this, the TS file don't run. Nobody knows, no browser knows how to run the TypeScript file. So eventually these TypeScript files are converted into JavaScript file. This is how usually the transaction happens. And then browser actually runs them. Now you have to tell your TypeScript that how should I convert these files into JavaScript. So they can actually use CommonJS or they can use module. In this one, let's try the CommonJS. So in the package itself, most of the time you see this as module. That's why I made this as module. But since we are not writing JavaScript on our own, our TypeScript compiler will write it. And I found that in this particular case, CommonJS is actually much more useful. So I'll just go ahead and say CommonJS. And that's the reason, not because we will be writing it. All right. So based on the setting, if you are using different module, go ahead and use that. Since I'm using it, that's why we have. Also notice here, the output directory is .dist. That means we want to use the distribution folder. You can name this folder anything. It's just a folder name, nothing else, nothing new, nothing extraordinary. Now let's go back into the package. Let's change the script as well. So first the script is going to be start. That is probably going to be used on the server itself, and we can use it for lots of purpose. So we have this TSC. This is how you invoke the TypeScript, and we can run the script. That node will be responsible for running this dist, and inside the dist you will find index.js. Right now it is not there, but as the TypeScript will go ahead and run this, they will introduce this folder automatically. Basically, they'll generate this folder for us. We'll also have a dev script, and how the dev script is going to work is nodemon. But remember, we don't have any JavaScript to run as of now. So what we're going to do is --exec, which is for execution. And then we are going to introduce that I want to run something. And again, we have to put up a slash again. And now I can have one more this. There we go. Now inside this, I'm going to say npm run start, so that automatically the start script run and it generates the new JavaScript files for me and works nicely with that. Now, apart from this, I'll also add some of the things. We need the extension of TypeScript to run this, and we will be running it in the watch mode. And where should you be watching? Let's go ahead and create a source folder. So just go ahead and watch the entire source folder. We don't have it now. We will create it. No problem there. Go ahead and create a new folder, src. So entire source folder will be watched. If you have any other folder, just go ahead and watch that. No big deal. So with this, now hopefully our folder will be watched and monitored. If there is anything else, we can just again come back and fix the stuff. No big deal there. Next up, what comes up is a new file actually, which is going to be .env. I'll not be sharing the .env, so I'll just go ahead and create another one, which is .env.example. And I accidentally created them in the wrong place. They should be inside this one. Yes, please move it. This one also should be inside the backend folder itself. Move it there. Now inside these, you will need a few things named almost exactly same. Since we are writing our custom backend, they don't much, but keep them almost the same name. So first of all is the stream key. And this is actually a public key that we have to grab from the stream, Getstream actually. I'll walk you through that part as well. Then it's actually super easy. Then we have a stream API secret. This is secret. This is like a private key. So this is where we have to enter our private key. And then we have the OpenAI key. Keep it very, very secure. And you have to write them in a specific way only. Otherwise, you have to pass on this as an option that this is where the key lies. So if you name it as OpenAI _ API key, OpenAI automatically knows that this is how I'm going to pick the key from the environment variables. So this is your OpenAI key. And then we also need Tevili API key. Tevili is going to be our agent, which will look on the internet, internet agent, which will look on the internet and will get the relevant information for us. Save this. This is what we'll be using. I'll just share this one with you on the environment variable example. Looks good and absolutely fine. Another thing that we are going to do for this application is to make sure that we load these environment variable nice and easy so that we know that what's happening, how is it happening. All right, so what we can do is we have everything installed, so no need to worry on that. Now inside this, let's keep everything inside the source so that it's easier. So inside the source, let's create the very first file, and this one is going to be server client. .ts, we'll be using TypeScript. Don't worry if you don't know the TypeScript. I'll walk you through how the TypeScript works and how the entire thing goes on. It's super easy. Don't you worry on that part. So first thing that we're going to do is import. We will need stream chat here. So we'll go ahead and say import. It's a named import. So we'll just go ahead and say stream chat. That's the one I'm looking up for. With the TypeScript, I love the suggestion. The first thing we're going to do is export a few API keys. So we're going to say export const API key. That's going to come from process.env dot. I thought there will be suggestion here. I don't have a suggestion. That's bad. I'll just go up here. This is the one I'm looking up for. Copy that and paste that. And also you have to do is as string so that we know this is casted as string 100%. We need another one of it, which is this one. So stream API secret. There we go. This is also casted as a string, but this is API secret. Secret. There we go. So both of them are available to us now. The next part is going to do is if we don't have any of these keys, that means things cannot work. So we'll just put up an if condition. If we don't have API key or we don't have API secret, then we'll not proceed. Instead of that, we will throw a new error, and that error is going to be simply missing required environment variables for stream API key and stream API secret, so that we know exactly what we are looking up for. If this is all good, then we can go ahead and say export const, and we can create a server client. This is what the stream chat is going to give to us. And we'll go ahead and say stream chat. And all it takes is just 2 parameters, as you can see here as well, key. So here is your key, API key. What else do you need? Of course, the secret, because the key is in the 2 part. So API secret, and that's it. That's your very first code that we have written to make the configuration all up and running. Apart from this, we will need some of the types as well, because we are in the TypeScript. Again, if you're not using TypeScript, that's okay. But if we are using the TypeScript, then we need the types to happen as well. Again, it's totally dependent on you that where you are keeping your types. I would love to keep them inside an additional folder. So I'll create a new folder, and this folder is going to be agents, because this is where we are going to keep all of our agents. And let's go ahead and create the first agent, first type actually, not even the agent. New file, and cannot write anything in it. Right click new. Yep, now I can write types.ts so that we can import the types and work with that. So first of all, we are going to import the type, and these are going to come from stream chat. What we need from here is first of all channel, because channel is on the left side, whatever the channels are there which are created by user. We'll also see that we will have a stream chat and we will have a user. This is the one. All right, now define the type for each one of them. We will import and export an interface. Interface is something which is just the TypeScript specific. This is just like how you want to define the structure of your variable. This is a complex variable. So for the interface, we'll say we will have a user. Optionally, it might be there, it might not be there, but if it is there, it should be of type of user, which is given by the stream chat. We also might have the channel, and if the user is there, obviously the channel will be there. This will be of type channel. Again, we just define the channel just like that. We'll also have a chat client, which is going to be stream chat. That's why we imported them. All right. We'll also get a method. Let's call this one as get last interaction. This will help us to get all the number of interactions that we had previously in the same chat. So this is going to be a method. We don't define the method. We just say this is a method which is going to give us a number back. That's it. We'll also have an init to initialize the chat so that we have to prepare everything. This is obviously going to be a method which returns you back a promise. And we say that we don't know what will come inside the promise. So when you don't know what, you don't care about what comes inside the promise, you just say void. And that's it. Void means nothing is for C++ and C concept. This is TypeScript, it's different. And we'll also have a dispose method. So once our chat is all done, we'll just call the dispose method and we'll do all the cleanup. This is again going to be a promise. And once the promise is there, we can just say, I don't care what it returns. That's okay, that's fine. So that's the agent interface that we have defined. Now we have to define the platform as well. So for that, we will just use enum because we'll give the user only 2 options. So this is going to be my agent platform. Feel free to extend it once you learn the concepts. This one is going to be OpenAI, and this one is going to be OpenAI. Another one that we will have is writing assistant, writing underscore assistant. There we go, nice and easy. Writing assistant. Looks good. So these are our enum. We can always loop through them or whatever we need. Now, once we are done with this, we will also get some of the writing messages. So there are a couple of states in which user can be. So this will be extended writing features for us. So export interface, and we will have writing. Writing message. Yes, I can write. There we go. And in this, we are going to have everything as custom. This custom can be there, cannot be there. So this is going to be just an optional thing. What do we have inside this custom? Let me show you. So once you have these custom message, you will have a couple of things. First of all, you can have suggestions. So maybe you have suggestions which are optional, might be there, might not be there. But if it's there, usually the suggestions in these kinds of application are an array of string, and that's how you write that. Suggestions, that's an array of string. Now, similarly, we can have some of that writing task as well. So what the interface is doing, the writing, how do you write the message? That's all what we are defining. And these are all optional there. I will go ahead and say there is a writing task. So that might be a string. And we might have other thing as well, like message type, what kind of message you are sending to us. And again, depends on how you have worked in the past with the AI. AI can actually take messages in different roles. So some can be system, some can be user or developer, some are AI response. So these are different ones. How much do you support? It depends on you. So we'll just say we support a user input. Obviously, we have to support that because that's where the user send the message. AI can also respond to it. So that will be an AI response, or it can be a system message. So you are a helpful assistant, that kind of a message. We will keep this here. So we'll just have a system message. All right, looks good. Save that. And let me show you the whole. So this is how it looks like. Not too bad. I agree on that part. So we just have finished the bare minimum working of it. And that's it. So far, let me just summarize this, what we have done so far. It's not really that bad. So we have populated our application, written some TypeScript configuration. Based on this, we have modified the package.json. Keep it about 20. That's good practice now. 18 is deprecated now from all places. And we created a server client, very basic code. We just imported our API keys properly. And that's it, nothing much. We haven't, yes, I know, I'm well aware that we haven't created much of the things that how it needs to be done and all these things. We will do that very soon. I know we haven't created our index.js as well. Let's go ahead and create that actually. I was thinking to end the video, but let's create the index as well. Not a big deal. So let's create this one. Call this one as index.ts. All right. So obviously a few things needs to come into the index. First of all is course. So course from course. Once this is there, we need to import the .env. The syntax is now much cleaner. All you have to say is .env, and we can just say /config. That's the syntax these days. Again, no need to pass on much of the stuff. It just works out of the box these days. We will need express as well. So let's go ahead and say express, not like that. Express from express looks good. And that's it. Let's create an app from express. So we'll just say const app will be created from express. There we go, standard syntax. Let's also allow to use the JSON import. So write a middleware with the use functionality that says express.json with a method. It's a function. And then we'll use the course as well. So we'll just say app.use. Again, whenever you see use, that's a middleware. We'll say course. And in that, we will provide an option. The option is going to be, I will give you a origin. Right now, we'll keep a bad practice, which is an origin of star. Whenever you finish the project or you host the project, remove the star. Right now, it accepts the request from everywhere. We don't want it to happen. Usually we want it to happen once things are there. You want to put an actual URL in this one. All right. So let's create a very basic route so that the server can actually be up and running. So we'll just say app.get. We'll call this one as a slash. We'll serve something on this. This one will be basic request response, just like that. A simple callback, res.json, and that will take an object. We'll just provide a message just like this. And the message is going to be AI writing assistant. Server is running. And once we are done with this, we will also see whether our API keys are loading or not. So we'll just go ahead and say the API key, and the API key is going to come from API key. There we go. I'm just loading them so that I can see whether they're properly loading or not, whatever I'm putting them up. We will also go ahead and we don't need to put the secret out. That's it. All right, so this one seems okay now. Let's go ahead and see that if we can actually run this in the current status itself, which should be fairly easy. Let's say we will have a port to run this because we want to deploy it. So keep the port always into a separate variable. And this one is going to be process.env.port. We don't have it, so we'll provide an optional one, 3000. If we don't have it, just use this one. App.listen. And this one is going to listen on the port. We'll have a callback. And once we have the callback, we'll say console.log. All right, so let's use a backtick and we'll say server is running at http://localhost : and we can say port, whatever the port number is there. All right, so now let's give it a chance. And we'll just say npm run dev. If you forgot, we have a package.json, we have npm run dev. Hopefully that should work, otherwise we need to tweak it. Npm run dev, and looks okay. And as you can see, the dist folder came in, which has a lot of stuff. We are not worried on that. All I want to do is visit this. I should actually technically be firing an API call through the Postman. Let's actually do that properly. Let me open up my Postman, and we have so much things going on in this. I can just say save. I don't know where I was working. Don't even remember that. You can go away. Yeah, you can also get save. All right. So we'll just remove everything and we'll create a new request. I'll just call it a blank collection. And this one is AI agent. And inside the AI agent, let's add a request. This one is just a test. Now we have this URL. Let's send a GET request on this. And there we go. We can see the messages coming in. We can see the API keys are coming in. Pretty good work for the very start of the application. And now I can just go ahead and close all. There we go. We are running nicely there. Now in the next part of the video, we are going to design actually the brain of this entire application. And this brain is going to be a bit complex. This is the most important part of this application, and it's written in a kind of a traditional way. The reason why I'm saying it's written in a traditional way, because even if you look at the types we have defined, we said here that there will be some init method which will initialize the whole thing. We will have a dispose method which is going to just do the memory cleanup, which is rarely being talked, but we are going to talk them about here as well. So it is going to be a bit of a complex piece, but don't worry, I'll explain each and everything that we are writing, why we are writing, what's happening, and how all of that. But this is going to take some time, so be prepared for that. That is it. That's it, and let's catch you up in the next video. For you, it's going to be probably just the next second. All right, let's go ahead and design the brain of this application now. Don't worry, it's actually easy. It just is a big file. That's why it looks really complex, but it is not. The writing part is not that big. So let's go ahead and clean this up. And we would like to keep them into a folder. So we'll actually use the agents folder itself. And in the agent, let's right click and create a new folder where we are discussing and talking with OpenAI. Maybe later on you want to extend this application for Anthropic or something else, that's okay, but we are keeping it for OpenAI as of now. By the way, you can use the Gemini SDK for OpenAI as well. They give the compatibility as well. I'll walk you through with that part as well in a minute so that you can actually turn this entire application in Gemini as well in case you want to. But first, let me go ahead and create a new file and then I'll walk you through. I'll call this one as simply OpenAI response handler. This is going to be the file which will do heavy lifting for us. Now, let me also walk you through with the OpenAI SDK. So actually, Gemini also provide OpenAI SDK compatible SDK. So what you will notice that if I go on to this very first link, what you'll notice that the code that we write is exactly same. All you have to do is use the Gemini key. You can still use the OpenAI, the exact same code. Just change these two things. The URL, now you're hitting the URL for the Gemini and you're using the Gemini key. So basically, technically what we are writing is very, very robust code. It can be utilized anywhere. By the way, it's the same is available for Anthropic and pretty much almost everywhere. So OpenAI is the standard. That's the thing. So we'll just bring the OpenAI from OpenAI. We will also go ahead and bring some of the assistant stream type as well. And these are like just for types so that we don't get the type errors for the TypeScript. So I'll just go ahead and say import type and we will be bringing the assistant. Is this one? Yep, this is the one. But we want assistant stream because we will be streaming this. So, and assistant stream. I think it's not the stream. Let me change this. So OpenAI, this one is actually inside the lib. Yep, that's the one. And this should be here. So assistant stream. There we go. These are just types. No functionality is getting imported in this one. Similarly, we will go ahead and import some type from stream chat. This is the one who will do the heavy lifting for us. So in this one, first of all, let's bring the channel. We are going to bring the event. We'll get the message response. We'll also get the stream chat. Stream chat, that's the one. Now after that, we are going to export a simple class and we'll be using this like left and right everywhere. So this one is going to be OpenAI response handler. All right, looks good. Now the first thing that we're going to do is we're going to create a few variables and we'll declare the constructor as well. So first, let's go ahead and focus on the variables because there are a lot of these, because we will have a lot of variables available up here. Our goal and focus is to understand that why does this variable exist and what they actually do. So let me go ahead and write them one by one and I'll keep on explaining them as well. We'll keep all of them as private. Private. Why are you not? What's the issue? Why the word private? Am I mistyping it? Anyways, let's go ahead and write that first. So the first variable that we have is message text, and that's going to be a string here. Now the role of the message text is simple. It accumulates the complete AI response text as it streams in the real time. Simple, nothing much, nothing fancy. We will also have a private chunk counter, and that's going to get a value of 0. This one is simply to track the number of text chunks received for debugging and monitoring. Basically, it can send a lot of chunks. We just keep in mind that how many chunks actually are coming in. Super simple. Then we'll also go ahead and have a simple run ID. This is going to be empty string as of now. The run ID simply stores the unique OpenAI run identifier for the API operations. Maybe you want to cancel that, that's also fine, but it's a simple unique request that, hey, this is one I'm generating and I don't repeat that myself again in the second request. So next one is done. And by default, it's false. This is simply to guard the flag, guard flag to prevent the operation on disposed handlers and avoid memory leaks and stuff. Basically, it's a flag for us saying that, hey, you are all done. And then we'll have another one, which is going to be last update time, and that's going to be 0. All right. I hope there is no issue in these variables. Simple text keeps the track of chunk because we are streaming the data. So have you seen the ChatGPT? I'm pretty sure you have. So it doesn't send all the data at once. It sends you in the chunks. Like it keeps the showing animation of typing like that. So for that, the chunk counter is important. Run ID, so that each request, when it starts to run or to give you the message back, it has a run ID. It's a unique ID. Then we have is done, is false, and updated. So pretty good, pretty easy. All right. Now, once we are here, let's go ahead and declare a constructor. So the constructor that we have is going to be like this basic, and we will accept some of the data. There we go. What kind of data you are expecting? A lot of them. Let me just walk you through. And all of them is going to be read only. And I'll just go ahead and copy this because I'll be using them a lot. The first one is going to be OpenAI. And this will be coming from the OpenAI. There we go. And as soon as we start this, or anybody who uses this class, it has to provide all this data. Otherwise, we cannot actually function this. Now, once we have this, we have OpenAI thread. So we know that which thread we are working on. And again, this is also given to you by OpenAI. OpenAI knows that these kinds of applications are being built. So this is the beta.threads.thread. So OpenAI knows that this kind of a stuff happens and are being given. By the way, I forgot a comma. And I forgot a comma here as well. Let me expand this. We can do it. All right. What's the next one that we want? We want an assistant stream as well. Assistant stream. As we go through, I'll walk you through that, why they are used, what they actually do. So nothing much. This is assistant stream that we're having. In case you remember, this is the assistant stream we brought in. And as we will code, I'll walk you through this part as well. Don't you worry. And after that, we have a chat client as well. And this is the stream chat. So stream chat, we have a channel as well. We are maintaining a channel for each user, just like ChatGPT does. So this is going to be read only channel, and that's going to be our channel. Again, stream chat gives us that, or the Getstream gives it to us. Then another one we have is message. This is what we have been waiting for. And this is our message response. And then we have a simple, again, I forgot a comma. I'll do that. Don't you worry on that. On dispose. This is the one that will help us to prevent any kind of memory leak that we have. All right. There we go. And we simply go ahead. We don't care what it returns. It just needs to run so that it can take care of the memory issues what we have. And at the end, let's put up some commas so that it doesn't bother us much. All right, good enough. Now, once we are here, we need to learn how we can handle stop generating as well. So here in the constructor itself, right now this method doesn't exist, but it will be very soon. So we'll say this dot chat client dot on. So we are working on kind of sockets. We are listening on some of the events. So we will be passing on an event, which we name it as AI indicator dot stop. And you can name your event whatever you like. But if I go ahead and use this event, then we simply go ahead and say this dot handle stop generating. And this method doesn't exist, but don't you worry part. This is something that we will learn eventually. Basically, what we are doing is we are using a signal here. So this is our simple application. So this is our own server. And this is the OpenAI server. So this is OpenAI. And this is our server, which we are calling up. So this is server. And what's happening, you will be keep on getting this. Now you are continuously receiving the data from the OpenAI. That's what the stream is. But once it has stopped generating this, we will actually make sure that we receive this kind of a data. And this is all done by the Getstream, that it sends a special signal that, hey, I'm sending a special signal that this was my last bit of data and I'm done generating. So for this, we are using this AI indicator that, hey, there will be an indicator on which a stop event will be streamed. And you can handle this by running this stop generating or any other method. You can name this whatever you like. We will be creating this method, don't you worry. We actually should do that right now so that it stops yelling at us. We'll just go ahead and say private handle stop generating, which is going to be async, and it will receive an event, which obviously will be a type of event, and it will do something with it. What we will figure out later on. But this will be responsible that, okay, all generated. So if I have an indicator, I'll stop that and all these stuff. So I'll do that. All right, so far, not so bad. No, I'm deliberately spending more time on this because this is the meat part of this. All right. So once this is done, this is just preparation. We haven't written any logic yet so far. And yes, all the time you have to do this much of preparation when you're working on this. So what I'll do is I'll go ahead and copy this so that I can walk you through. There are a couple of other methods that we have to do. The first one is going to be run, but this doesn't need to be a private method. It can be just a regular method. So this is going to be a run method. I will walk you through what the run does. Basically, it just runs the application. This is basically an orchestrator of the application. We will have one more method just like this, which will be dispose. And yes, this is the same method which is responsible for cleaning up all the resources as well. Based on the events that we are receiving, we have the handle, this one. Now we need a couple of more handlers as well. Let me walk you through. The next one that we will be using is handle stream event. We will work on how this works and all these things. This probably doesn't need to be a sync itself. It can just work directly as well, but we'll see. But it definitely receives an event. No harm in us keeping it async as of now. And apart from that, once we have handled the stream, we need to handle the error as well. So handle error, that's why I call this one. This one is a brain of the entire application. And apart from this, we also have a third-party one which performs the web search for us. So let's call this one as perform web search. All right. So in the term of how the AI talks, this is our tool. Tool simply means that does some operation or some task for you other than the AI stuff. So it could be a tool for handling things like GitHub request, maybe for the database request. So all these things can be done. But right now this is here. Now in this, we don't receive any kind of event. We actually receive a query string because it is going to do a web search. So let's call this one as query. And in fact, let's write this on here as well. This one is going to be a simple of type string, and that's it. Let's actually finish this one because this is comparatively much easier to work on with this one. And what does it return back to you? It's probably going to return you a promise. And in the promise, you will have some data. So let's call this one as a string. Right now, you don't return that. That's okay. It's a reminder to myself that, hey, we have to do this. The step one is to grab the key. So I'll just go ahead and say process.env. No suggestion. So I have to grab it. Without this key, it doesn't work. So I'll just go ahead and close this. There we go. There's an extra T, I know. There we go. Let's go ahead and keep this into a variable. And we are going to call this one as Tavili API key. There we go. Now you have key. If you don't have key, what will happen? We'll take care of that scenario first. If we don't have this key, then we are going to go ahead and throw an error. So we'll return a JSON.stringify, and we are going to return this error that says web search is not available, obvious reasons, API key not configured. I think that's a good enough message for us to understand that why is it not happening. Assuming that it's happening, so how do we do that? First of all, keep ourselves in the track. So let's do a simple console log and just say performing a web search for, and whatever the query you have mentioned. So I need that query. Good enough, good indicator for us. Then we simply go ahead and open up a simple try catch so that we can get a response. Getting a response is actually easy. All you have to do is await. You can use Axios as well, but in this case, let's go fetch. It's a simple get request. No, it should be a post request because we need to send the authorization and a lot of stuff in the body as well. So let's do a post search. So The URL that Tavili gives you is HTTP. It's a very simple one. Once you see this, you'll always remember this. By the way, you can look into the docs as well. HTTPS api.tavili.com/search. Told you, super easy to remember. Const response. You can hit the get request here, but we do have a post request, so we'll just open this up just like this. And first of all is we do have some method. Let's call this one as post. Then we have some headers. What headers do you want to send? First of all is going to be content dash type. I wish there would be a suggestion here, but nope. And that's going to be an application slash JSON. Good enough. And then another one is the authorization. So we're going to go ahead and say authorization. That's the one. And for the authorization, what we are sending is backticks. We'll say bearer space and the token. That's your key. And here we can say Tavili API key. That's what you have to send. Good enough. Now we have to send the body as well, the payload basically. In the payload, how much do you want to configure is totally dependent on you. I'll just go ahead and say JSON.stringify. JSON stringify. All right. This is the one that we want to send. First parameter is query itself, which will be query, standard stuff. And then what kind of search you want to do, you can actually go ahead and say search depth as well. There are a couple of options that they give to you. I'll go ahead and say, if we're doing it, let's go ahead and do advanced. But there's another one, advanced and basic and all these stuffs. And then we can also say max result, how many result you want to give it back. I'll say 5 is good enough. You can go with 3 as well. Then we will put up an include. And by the way, these are all coming up from the docs itself. Include answer, which is going to be true, so that it includes the answer, whatever it has found for us. And we'll say include raw, come on, raw, I can write that, include raw content so that you can see that how you have done that deep research. All right, let's keep it this much only. By the way, there are other options as well, but I'll still keep it this much only. Pretty good. Let's go ahead and shrink this so that we can see what's happening. All right, once we have the response, first of all, let's check whether if we don't have a response. So if we don't have response dot OK, so if that's not being received, then we probably want to have an error response as well. So response dot text, and we can await. They have a beautiful error handling library as well, and error text, just like that. Now we have error text. We should actually get a console log for ourselves as well. So console.log, and we'll say Tavili search failed. These error messages will help us to actually debug later on when we are stuck. And for what you are failed to search, let's go ahead and throw that query as well. And after that, we can have the error text as well. Let's keep it outside. Error text, let's throw that just for fun. Once this is all done, we will just go ahead and return a JSON.stringify. And there we go. In this, we will go ahead and say, this is my error. And we will say search failed with status. And we can just use a status like this, response.status. Good enough. And details, we can send the details as error text, forgot a comma. There we go. All right. Quite nicely and in detail, we have handled the error. Let's go there. Assuming that there is no error now, we can just go ahead and grab the data. So response.json, there we go. Await, of course, it will take some time, and we will have the data. Now we can throw this data directly as well, but let's go ahead and do a console log as well for us. It would be easier for us later on. And we'll say Tavili search successful full for, so that we know which query we are making or where on which query the thing is failing up. All right, good enough. And once we have all of this, we are going to go ahead and return the JSON.stringify, and we'll just send the data entirely. All right, good enough. And for the error, not a big deal. We can handle the error part. And there we go. So looks okay as of now, apart from that one small error which is bothering us. But don't worry, we will handle that part as well because we are not done yet. Let's finish this first. So in the error part, if we receive an error, we do a console log, and we can do an error log as well. And for this, we'll say an exception occurred during web search for. Good enough. And if that's the case, we can actually return an error instance as well. Let's go ahead and say return JSON.stringify. And we can just say error is going to be an exception occurred during web search, and we'll receive a, we can send a message as well, but I think that's okay. All right, looks decent as of now, but let's explore it more. We can technically send more data in the error part, like we can send an instance of error, what kind of error, but this is okay. And I think this should all make it happy. Yep, looks okay. All right, so our perform web search is okay. And in case you want to know about the technicalities of it, this is called as tools. And yes, your API or your OpenAI will be completely able to access this one. Now, apart from this, what I will do is I will walk you through with couple of more things as well. Like we can handle the error as well after this. This should be fairly easy. Now to handle the error, you will receive the error, not the event. So let's call this one as error. And this will be a type of error, just like that. And once we are here, let's keep it async, no problem there. And we will say that if we got this dot is done, if we have this, then there is nothing to worry about. We can just go ahead and return. That means, hey, we are all done. No need to handle the error or anything. All is being done. Apart from this, we can just go ahead and do some more fun stuff. So we'll just go ahead and say this dot channel. Now this is where we use the channel. If you remember, we don't have it yet. Let me open this up. Yeah, here it is. So this is the channel that we'll be using. So based on this channel, what we can do is this can actually send event. Event are just a kind of a socket IO. We'll be sending multiple of these events. So we will wait for this channel, and here we can have a different type. So this is basically a payload that I can send. So let's call this one as AI underscore indicator. And this one is update. So I'm sending one update to this. After this, I'll send the AI state as well. So we'll be playing around with a lot of AI state, that where you are right now. Is it all good? Is it all not good? So notice here we have the AI state of checking the sources, state errors. So obviously this one is an error, so we'll use this one. Thanks TypeScript. We will also go ahead and get a CID, which is basically a channel ID and message ID. This dot message dot CID. So this is the one. And we'll also send the message ID. By the way, the CID is actually channel ID. So we'll have a message underscore ID, and this will be this dot message and dot ID. So this is actually being sent so that we can actually update the errors and all these things wherever the error happens. We don't want to update all the channels. We want to update in only this message, that this is the message which created the problem in this particular channel. Will remind us that, hey, this was an error, and this is how we update. So this is basically sending a socket update to us. Now after this, we will handle another kind of error. By the way, you can handle a lot of type of error. Another one, this is for the chat client. So chat client can have actually one more thing. You can see we have a partial update, partial poll. Maybe your client was not able to get all the data. So technically on these complex apps, we have all these things being handled. I'll just show you one because I don't want to write all of them, but let's just say. So notice here it says update the given message ID while retaining the additional properties. So response that includes the updated message. Okay, so what we're going to do in this one. So once you have this one, the first thing that you have to provide is the ID of it. So obviously we have a message and this has an ID. Fair enough. Now others are just these ones, and we want to use a set here. Yeah, this is a property setter. So this is a pre-built method. You just set the values in here and you don't directly override that. You use the set method for this. So we'll just say text. What do you want to update in the text? There is nothing much. There are two things, text and message. And in this case, I'll just go ahead and say I have an error, and in that I do have a message that might be there, might not be there. So if it's not there, I'll go ahead and say error generating the message. All right, fair enough. And we do have a message as well. That can be error. I'll go ahead and convert this into toString. There we go. All right. And once we are all done with this, then this means that, hey, we are handling the error. But there is one more thing in here. I think we haven't written this. Yep. We need to actually call this dispose as well. The dispose will be responsible for clearing. So we are not generating anything more. So in that case, hey, these are the errors we have handled. This is the event. This is the most important part. Handle as much error as you wish to have. And once you're done this, dispose. All memory and everything needs to be cleaned. So await this dot dispose. There we go. We call that. It does all the cleanup for us. Just like you see in the movies, somebody needs to do the cleanup. So it does all that for you. By the way, this dispose is actually super easy. Let's go ahead and write that since we are talking so much about it. So once you call this dispose, what it does is, first of all, we'll check the same thing. If everything is all done, hey, I'm okay. I don't need to do much on this one. So is done. We are keeping this flag all around the places. If this is there, then go ahead and simply say return, all good, all okay. But if that is not the case, then we have to do some of the cleanup, and that's super easy. First of all, this dot is done. That needs to be true now because technically everything is all done now. And we'll also go ahead and say, hey, we do have a chat client. In that chat client, we'll turn this off now. This is remove the event listener. Notice here it says remove the event listener. And in case you're wondering, yeah, this is the same chat client that we are getting. This is the chat client, which is given to us by the stream chat itself. That's why it has so many of these methods. Anyways, where was I? Here somewhere. Here it is. So I'm getting this as off. Now, once I make this that, okay, this dispose is off, I actually have to stream some of the events as well. I will name this one as AI indicator dot stop. And the next part is, we'll just go ahead and say this dot handle stop generating. This will handle rest of the thing. And we can just go ahead and say this dot on dispose. Why there's an extra L? On dispose, and we can just run this. All right, this is property on dispose does not exist. This shouldn't be happening, but let me go ahead and check this. It should be available to us in the constructor. Oh, my bad. Typos, sorry. And this should be all good now. All right. So as I told you, and this, you can call this as much as time. This is the breaker point where everything is when done because we are turning this on. So even if we call this again, this should exit from here itself. Good enough, good strategy to make sure that it is 100% over. Although it's not needed, it's a little bit much, but okay, I get that. All right, now we have handle stop generating. All right, as you can see now that we have a flow, we haven't generated any message. We are just taking precautions here. Handle stream event is where we actually handle the stream. But what happens when we actually stop generating? This is again super easy. Most of the part we have already seen. What happens when there is error? Similar to that, we can actually manage handle stop generating. All right, that is easy one. This one will also receive an event so that it can stop generating the event. So we can check this if this dot, you get it, is done is there. Then we can just go ahead and return. Optionally, we can check for more thing as well. Like for example, if the event dot message dot id is not equals to this dot message dot id. So the event that is being sent, if the event ID doesn't match with the message ID that is currently running in this class, in that case, we can just go ahead and say that, hey, I'm not interested in going with that. And let me just go ahead and finish this. Then I'll see that why this is creating a problem. In that case, we can just go ahead and return. Why are you having an issue? Event message is possibly undefined. That could be a case. And my bad, it is not event.message.id, it's actually underscore ID. It took me a while. So event will directly include, if it is a type of event, it will include a message ID and then the message ID, so returns. So I hope this part is okay. And by the way, I have mentioned some of these methods is private because they will be only used within the class itself. Some are directly available like dispose and run because anybody can actually use them. So that's the easy part. So how do we handle the stop generating? I know you have never seen that. That's okay. That's why I'll walk you through. I'll not ask you to, hey, guess this, because you have never seen that. That's okay. First of all, let's do a console log, and that console log will simply say stop generating message for, or stop generating for message. Generating for message. And we'll see that for what message we are actually stopping this generation. Message dot id. Yep, that's the one. Good enough. Now, how can we go ahead and simply say that we can stop this one? So if, first of all, let's check whether we have to do this or not. If there is an open, if there is no OpenAI, or if this dot OpenAI thread is not there, come on. I'm just excluding the scenarios where I don't even need to run anything. So this dot run ID. So if I don't have any run ID, if I don't have an OpenAI, if I don't have any OpenAI thread, why to do anything at all? You can just go ahead and return, because these are the things which are generating, which will be eventually generating the stuff. So I'm avoiding the scenarios here. All right, you will get that why this is important, because first of all, OpenAI is needed to actually generate something. If OpenAI is generating something, it needs an OpenAI thread as well. And if OpenAI thread is there, we should have a run ID or the run thread itself. Fair enough. And eventually you'll see that this actually comes directly from the docs itself, nothing much. And let's do a try catch. In that, we are going to go ahead and simply cancel a thread. That's all we have to do. So let me show you how this works. This dot OpenAI, and this OpenAI has this beta, and this has threads, and threads has this runs method. Yes, a lot. And there you find all these create and poll steps and all of that. And what you're going to see is cancel. Although it's deprecated, this says you don't need it, but I'll still use this and it works absolutely fine. So just see this is deprecated, and probably they will update this soon in their docs. They haven't done it yet. So this dot OpenAI thread, this one is required, the ID of the thread actually. And after that, it also sees this dot run ID. So once you pass this, that's it. It actually stops generating. And why are you having this issue on this one, this dot run ID? String is not assignable, cancel run params. All right, so this took me some dig up that how to find this and why this was giving an error. And literally I went into the node modules and saw where this was all written. So this is the method that we are calling. Yes, usually you don't go that much, but sometimes when the packages are new and constantly changing, especially OpenAI, I jump into them. So it requires a thread ID, which is of type string, run ID, which is also we are giving a type of string, and then we have some options. And what I did is after that is I simply came up here and provided all option as like this, nothing, and then saved it, and all errors were gone. But surprisingly, after that, if I remove this also, all errors are gone. I don't know what's these typing. And by the way, this cancel that you see, I technically can remove this as well. All I have to do is remove this deprecated. So if you go ahead and change this deprecated, I shouldn't be doing that. Not a good idea to change anything. It's just good for reading. Then that will also be gone. Anyways, we are good to go now that we have all these things. And yes, these are the fun stuff which actually helps me to understand, to learn a lot of things. Anyways, so this is the main part where we simply cancel the all generation of the thing. That's the part one. And in the error, we'll just go ahead and shortcut this one. A simple console log, and in fact, a console error that simply says error cancelling run. And we'll simply just throw the error. Last thing that we have to do in this handle stop generating is send an event so that it knows that really all things are gone. So basically we are playing a lot with the sockets. So we'll say this dot channel dot send event, and what event we are sending. All right, nothing much. We'll send the type, the channel ID and message ID. Message ID and channel ID will send every single time, and type is obviously you have to send. So this one will be AI indicator, and we have an event of dot clear. So I was able to do all the clear. Send the channel ID, and the channel ID is going to be this dot message dot CID. And similar to this, we have one which is just the ID, and I can just say this is ID, or we can say message ID. There we go. That's it. And once we are all done, one thing we always and always are going to go ahead and say this dot dispose, so that you can just clean up all the things. All right. So as you can see, for the first time that you see, it's a lot. But if you now look at this, if it is all done, we don't do anything. If we don't have an instance of OpenAI, or the thread is not there, or ID is not there, then no point of doing anything. And all we are doing in this try catch, this is the main part in which we just query the OpenAI that, hey, stop running the threads that you have been running so that you don't waste my resources. And this is how we gracefully handle the generation part, so that it should not keep on generating the stuff. Then we simply send these events so that we can use them in the front end or wherever we like to simply get this, and then finally dispose. So as you can see, it's a lot at first, but these are all repeatable files. You can just literally copy these files, use them, a lot of these things, then you can do. So I guess that is it we are going to do. We have another two big methods that we have to work on with this. A run is basically an orchestration, so that's not much. We have the handle stream, I guess handle error. Yep, this is also we have done. So I'll just keep this. In the next video, we'll just handle the stream part, or in the next segment of the video, we'll just handle the stream part. This one is little bit involved. So I'll walk you through first with the what needs to happen in this method, and then we'll write the code because it is little bit involved. That is it for this video. Let's catch up in the next one. Okay, so let's go ahead and talk about the one thing which is remaining, that how do we handle the stream? Now, when you're handling the stream, basically what you're doing is handling different cases, and there could be a lot of cases, and we'll talk about them. The code that we write inside, once we know how to handle that, that's easy. First of all, we are going to go ahead and get this message. We need to extract some data out of it, and that's super easy. And you know what data we will be extracting, the channel ID and the ID of the message itself. So it will give you a CID, the channel ID, and the ID of the message itself. Fair enough. Now, the next part is pretty simple. You handle different cases. What could be the cases? The cases could be based on the event that you're receiving. So if you go ahead and check for event.event, that could be equal to some of the stuff. For example, we can have a thread dot run dot created. So maybe there is an event that where somebody is just trying to create a thread or a chat stream itself. In that case, what do you want to do? I just want to create it. So in that case, we will have a simple this dot run ID will create one. And how do we create one? We'll simply take this event, we'll take the data, and we'll just take the ID out of it. And that is all it takes. Why are you having the issue? Event.data is of type unknown. This shouldn't be the case. Let me check that. That actually could be the case. So we'll actually call this event not just an event. We'll actually change this one to OpenAI dot beta dot assistant suggestion. No suggestion. You should be giving me the suggestion. This is the one that we are looking for, assistant stream event. It should be giving me this. Let me just check that. Assistants, I guess. Yeah, that's the assistants. And now we should have assistant stream event. Yep, that is the one. Okay, found the culprit. Okay, so this is the first case we are handling, and obviously we'll have a similar else if. So what is the other case that can happen? And that's what we do. And don't worry, there are only 4 that can happen. So the first one is created. The second one is delta. Delta means an event is already running. And what we are doing is we are accepting some of the chunks of it. So we can just go like that. Okay, what do you want now? So this compares to be unintentional. The error, no, it is not unintentional. It is supposed to be here. Oops, my bad. It's thread run delta. It's actually message because we are receiving the message. That's why the message is going to be delta. There's another one similar. If you just hover over this or on this, let me just show you where I actually found this. So if I hit the Control Z, you'll see this. Now if you scroll this, you can see all the types of errors and thread can actually run. So thread can be in the queue, it can be completed, failed, and all of that. And I was searching that where is the delta? I couldn't find that. Then I realized, oh, this is not run. It's actually the message thread.message.delta, and then you see, all right, it is here. Sadly, that's in string, so it's very, very difficult. Now, the step 1 is to extract the content out of the delta. How do we do that? It's actually easy. You just simply say event.data.delta, and inside that you will find the content. Now, ChatGPT just gives you the one option. It used to give you many, so that's why we always say 0 now. Let's store this and call this one as text delta. There we go. Now you have extracted the text, and we have to check whether it is actually a text type. Yes, a lot of checking happens on the AI because AI is known for hallucinating and sending you any type of data. So if it is there, we'll just check this whether this is of type text, not the string. That's a straight textbook stuff. And then we'll also check whether the text delta has some text. If that is the case, then we have checked that, and now we want to update this partial message along with the date as well. And we should know that it should not be from the past itself. So we'll just go ahead and create a variable now, and this one is going to be date dot now, so that we have an existing date now. And before we have the date, once we have the date, we'll first add this message. So we have this, if you remember, we have this message. We can just add a property text into it, and that's going to be added, not just like fully this will be updated into existing data. And what data is going to be text delta dot text dot value if we have that. Otherwise we are going to append nothing into it. Once we have done this, now we have a date. And why do we have a date? Good question. We have the date because we don't want to continuously stream this, because this can overwhelm our clients. So we're going to send them only in 1 second. So if now is if now minus this dot last update time is more than 1000, that means 1 second has passed on, then only we are going to stream this. And this is just to make sure that your client doesn't get overwhelmed. So we have the chat client, it doesn't get overwhelmed. And we have this partial update message. We provide the ID of the message as well as some options. There we go, it's happy now. And again, whenever you pass the option, you have to set the options like this. And the option that we are using is text this dot message text. All right, once this is all done, then we simply go ahead and say this dot last updated time is going to be now, so that we update it. And after this, we'll say this dot, since we have updated a chunk, so we'll just go ahead and add 1 to it. So we have updated chunk counter. I hope now it becomes much more clear that why we have this much of the data and chunk counter and all these things, just to keep them update that, hey, we are still receiving the data and everything is done. Now there is obviously a case when the message is all done. So we can just go ahead and take this line entirely, copy this. Where do you end? I guess here, paste this. And you will receive some of the delta message, that means chunk, and you will have completed as well. So once the message is all completed, then we have to just close the things off. The first stuff is we are going to say that, hey, all data is all done. So this dot chat client, we are going to use again same partial update message. We are going to provide you an ID and some options. In the option, we'll use the set. As you can see now, it's a very kind of a common thing. So in the text, we are going to go ahead and say event dot data dot content. We still have some content in our buffer, so we'll just go ahead and say this is the first one dot type. If it is equals to the text, then we'll send the value. Otherwise, we'll just say, because there could be a last message that might come. So that's why I'm using it. So if it is text is there, then optionally I'm going to go ahead and say event dot data dot content. Give me that content. So I'll just extract this one dot text dot value. Or if it is not there, in that case, I'll just say this dot message text. So basically, I'm trying to just extract the last one piece of the message. Save that. There we go. We have set this up. Now we have to send the event as well, because it's all completed, so that if we are writing that, hey, AI is writing and all those indicators, so that we can change that. So we'll use the channel again. We'll send the event, send event. And the payload that we are sending with the event is going to be type. And then we have simply AI indicator. Instead of the clear, yeah, we can use the clear type. And we can send the channel ID and message ID. As I mentioned, we will always send them. We have the CID, we have the message ID, and that's ID. All right, fair enough. We have, these are the things that we have. We might have some of the steps created. Why steps? Because your thread is being created, that's great. Your thread has been completed, that's great. But there could be a chance that your AI might call a tool like web search or maybe a database search. So that can also be the case. So in that case, what AI does, it actually creates a step for you. So let's go ahead and handle that part. I know that's the most common part. That's the most bizarre thing that you have seen ever, but this is how you handle the AI parts. Okay. So in this, the thread might have run a step. As you can see, step can also be, and yeah, technically you have to handle all of them: cancelled, completed, delta, expired, failed, because your tool might fail, your tool calling might fail. But I'll handle just one part to show you this. This is the step created. And in that case, I'll just open this up and walk you through how this is being done. So I'll just go ahead and say if event dot data dot step details dot type is equals to message creation. If that's the case, then we'll just go ahead and send an event in this case. So this dot channel dot send event. What is the event that you want to send? Again, we want to send the type first, that, hey, what type of event is being created? And this one is AI indicator update. Good enough. And then we are sending the AI state as well. What's the state? The state that we have is AI is generating still, maybe doing a web search. And CID, which is going to be CID. And we also need to send the message ID, which is just the ID. All right, and you might be wondering, this is too much. But remember, I've just showed you how this created is handled. In the real world, in the production, you have to handle all of the cases as well. And that's why it's a little hard. It's involved. It's not like anybody can write the AI code. It actually takes a lot of stuff, a lot of handling. But with this, now you have a template, at least basic templates of how to handle the thing. So we have the handle the stream, we have handled the stop generating, handling the error and perform. Of course, these methods are a lot longer than I've shown you. I've just given you the taste of how it is to build the response handler of the OpenAI. Yeah, this is crazy, crazy amount of code. And people think that they can make the chat app like anything. No, you can't. It takes a lot of effort. And as we proceed further in the video, I'll walk you through more with a lot of code. Now the walkthrough of the code will start because writing all these code in front of you, this one was important because we had to discuss some stuff. Now from this point onwards, we are going to walk you through with most of the code as well. If you wish, you can just check in the repository as well. By the way, I need to close this node module. Enough of diving into this one. And from the next video, this is all the heavy lifting part. Remember, I told you this is the brain part. So yeah, brain is now being designed. All that's going to handle now is we're calling dispose sometimes. Sometimes we're calling stop generating. Sometimes we are calling, hey, handle the stream, and all these details, nothing to be much. One more thing which is still remaining is the init method. So init method is going to be something which initialize the thing, but we're not going to write in this one. What we're going to write is the run code of that, and that will be more of a walkthrough instead of just going through like writing line by line code. It doesn't make sense. So in the next video, I'll walk you through with the run part of it, that how do we orchestrate all these methods. So basically we just call them at certain events that, hey, run this or run that. That is it for this video. Let's catch up in the next one. All right, so now the code walkthrough starts. And again, this is such a really long that whatever we need to write and understand, that part is already done. Now it's exactly almost similar or kind of concept that we need to understand. So to write our main run function itself, we have to understand that these are all the steps that we have to do. So first step is listen for all the AI events in the real time. That's the first step in the run, which is the orchestration method. Then we have to send the updates to the chat so that as soon as the partial text arrives, so that they can update whether it's writing or AI is thinking or something like that. Then we also have to detect when the AI requests for certain tools. This is really, really interesting. So when AI requests for tools and run them, we have to send back the results, and sometimes we even have to send that, hey, it's calling a tool or something like that. We also have to handle the completion, failure, or continuation after the tools and loop until the run is done and then clean up. This is the whole algorithm that we wrote. And again, this looks like a lot of code, and it is. So let me just walk you through that what's happening in this one. So notice here, if I just shrink the run, we have already prepared a lot. So dispose and handle stop generation, and this was the preparation. This was the main part. Once I go into the run, these are just the collection of the data. That's it. Then we simply launch a try catch loop, and we keep on continuously do the things that we really want to do. All right, so that's the basic part of it. Then we simply go ahead and listen for the events in a continuation kind of a loop. And then we simply run this infinite loop until unless it is completed. So basically, if the text is continuously getting generated, we keep on listening to it and we can keep on processing that. Then we simply run a loop which constantly listens for the stream which is generated and takes the event out of it. And then we simply look for what is the event. Now the event could be of variety of type. The one major thing which we are worried about is the tool calling. So if the event actually shows us the event.thread.run.require action, if that means it requires an action, and usually the action could be like submit tool output. So there could be many of such things action. If I just look at this, we have just one tool which is going through. And if I just look for this one, shrink this, notice here, there could be an event where thread could be completed. This is super easy. We just mark it as complete. If the thread has failed, that is also super easy. We just handle that case. If this is all completed, we simply break out the loop. That is also okay. And if we don't have any tools, that is okay. That means we don't have any tool. So I hope now this seems easier. All right, if we leave this main part, or if we just shrink this whole thing, and don't talk about it, we simply go ahead, look up the stream, and we simply take the stream and look for the events. What are the events? The event could be, the thread could be completed. All right, I'll just mark it as complete and exit. If the thread is failed, all right, I have to mark it still as complete and handle the error. Great. If it is actually completed, all right, go out of it. And if there is no tool, then it's okay. I don't have to do anything in that case. We simply reset the tool output. But the major thing happens when there is a tool. What is our tool? In case you remember, web search is our tool. So what we're going to do in that case, we handle that tool. How do we handle that? That's the thing. we first send this update that, hey, some external AI tools are being requested or being required to perform this action. Now, this could be a tool to search the web. This could be a tool to search GitHub, database, entries in the Excel. There could be anything. And what we do is we simply look for the web search. Now, this is a syntax of how you call the tool. So the tool name is web search. And whenever a web search is being called, we simply go ahead and perform these actions. That's it. Perform web search. This is the tool that we have already designed. We simply go ahead, perform that, and take the data out of it. And that's it. That's all what we do. And how do we call that? That actually depends on our next part of this particular walkthrough of the code, in which we design this OpenAI agent. So this is a handler for the agent. The real magic comes up with the OpenAI agent. Let's go ahead and walk through. It looks like a lot, but it is not. These are super basic stuff. So you'll walk through. You've already seen how to write these handlers. Now this is almost same. And once you see this, that's it. It's a very repeatable code. So the step one is declaring a class, and then we have some of the variables. OpenAI, of course, for the OpenAI platform, OpenAI API. Then we have this assistant. This is the created assistant profile, which will have the name, model, instruction, tool. These are the assistant. Then we have the thread, conversation thread for maintaining the context between the messages. And then we have this last interaction. So this basically says, hey, when did you last time interacted with me? Basically, hey, this is timestamp of the user when it last interacted. And then we have this handlers. This is a list of open instances for the messages. So there could be a lot of them. So that's why we have an array. Once we're done this, I don't think we need to discuss more about the dispose. This is exactly same as we discussed in that part. Constructor obviously is there, but dispose is simple method which removes the new message and disconnects the stream chat. So basically cleanup of the part. Then after that, we have a simple get user because we want to get the user. Now this could be if your application is behind authentication, definitely you want to get the user from the database or something. I have kept it really simple so that I get just the basics of the client. Now, after that, we are checking the last interaction with that. It returns a timestamp of the last user when the last user was interacted. And then we have this big init method which initializes this. This actually, first of all, go ahead and creates an OpenAI instance. Once it creates that, that creates a custom assistant. And this is where the magic begins. Once a custom instance is or custom assistant is created, you first provide a name to it, then provide an instruction to it that, hey, what you have to do. We will write this method as well. Define the model, and this is the main part. This is where you define all the tools. This is okay temperature. But the way you define the tool, this is interesting. You have to provide a few properties when you define the tools. The first is, what is the tool? This is a code interpreter. What is this? This is a type, which is a function. The function is web search. And you define the description in it. Then you provide the parameter, what property will come, what the query, what it will look like, the description. And please don't shy away from this. This is required because all we are doing is NLP, natural language processing. And through the NLP, natural language processing, we are allowing our AI agent to actually invoke this method. And if I go ahead and look up here, these are the methods like get writing assistant prompt. So this is where you write a really, really long prompt. Look at this. And this is where we mention all the detail that what can happen, how it happens and everything. And we handle the message and all these things. So this is basically handling the message. And after that we go, this is very standard stuff. We have written all these things. And once you look at this, you will get a detail of it. Notice here, these are all same stuff that we have done in the past as well. It may be in the thinking stage and all these stuffs, pretty easy. Once we are into this, let me walk you through more onto this one. So we have this handle message, and before that we have this get writing assistant prompt as well. So what it basically does, it returns a string prompt describing how the AI should work. But this is what this, notice here, it returns. So this is basically a long prompt which has current date, instruction for when to use the web search, the style of formatting, how should you write, all of that, because we're making assistant for that. After that, we have the handle message. This has some of the guardrails that, hey, don't do anything if these things happen. If you don't have a message or if you don't have OpenAI or the thread, don't do anything, skips the empty messages as well. If there is no message, that's okay. Then we simply update the timestamps and goes work that. After that, you are going to see more of the events being sent as well, just like we did in the past. And yes, it is a lot. It is a lot. As you can see, we finally removed the handlers and stuff. And yes, I know this is a lot, but if you really want to build a production grade application, this is kind of a work that we had to do. I didn't want you to do it again. That's why I walked you through with the code. I'll give you the code in the GitHub repository as well. But yes, this took us like heart and everything to handle the message, to remove the handler. Yeah, a lot of events. And even still in this production grade application, we haven't handled all the cases. And that is what gets me crazy, that even after writing this much of the code, it's not really handling everything. So you can see how much it looks like. In most of the tutorial, you see that one person just writes the code and build the entire application. But these kinds of application, when we started writing, we realized it requires a team. And saying that, hey, I can build it on my own, you just watch the tutorial for 20 hours or 30 hours, that's not possible. You require a team to build this. You have also seen in the last last section as well that we are handling, or I'm teaching you just to handle 2 or 3 cases, or hardly in that one, just the one cases that we have. But we have so many other cases that we haven't handled. And that's why you require a big team to work on that. And I hope you got the idea now that this is really a crazy application that goes on. So that is it for this video. Let's go ahead and catch. I will give you a more of the code walkthrough in the upcoming videos. All right, so let's go ahead and take a tour of the final application. So I've loaded up the final application in my VS Code, and this is what we're going to understand. And then we're going to have a walkthrough of the front end as well. By the way, I'll push all the code in my GitHub repository and I will try to add more content onto this one because it's a fantastic, crazy problem to solve. Of course, it will take more time and more engineering effort, but I'm willing to do this because there's so much of learning in this. So what we're doing so far is we have done the stream chat integration, how many things we have to take care. And then on top of that, we have OpenAI's call. And stream chat is actually for chat UI and events. And it's a kind of an interface or a bridge between the OpenAI assistant APIs, the streaming API, as well as the custom AI logic that we have written, which might have tools or might not have. So let me walk you through one by one what we have done, and it will give you, again, the second time tour is much more easier than the first time. So the step one was to simply go ahead and work on the OpenAI agent. So we went into the handlers. Now, if you look at this, the constructor was basically how we handle that. We have a run orchestration. We'll talk about them. Dispose was pretty easy. We went through and clear up all the resources and stopped the AI indicator. All the events were streamed that, hey, we are all done generating this stuff. Then we are handling that when the AI stop generating the content, how do we do this? This is where we handled that, okay, this is all the cleanup we are going to do, and this is all the events we are going to stream once the AI assistant has stopped to generating the events. Similarly, we have the handle stream event, which has a lot of cases. There might be a case where a thread was created. There might be a case where some of the data chunk might be coming in. There was an event where the message was completed, and there could be an event for the step created. Step created is simply when the tools are being called. Right now it's one tool, but it can be hundreds of other tools. And in a complex application, yes, there can be hundreds of tools like that. And even there are startups which have dedicated engineers which actually write these tools day in and day out. We handle the errors and we perform the web search. This is basically our tool, and our AI just calls these tools where we calls an API and just work with that. Similar tool can be designed for Postgres, GitHub, Figma, you just name it. And then we design an orchestrator. Orchestrator is nothing which controls the thing. So in the run application, if you look at this, first of all, we extract the channel ID and message ID from here. We mark the completed as false because we are generating the things. The tools output is nothing right now. And then we have this current stream available. Now we went into a loop which is governed by this is completed. As long as it is false, it will keep on running because we have this exclamation. Now we listen to the current stream. So this is the event that we are constantly listening from the current stream, and we are handling the event. So if the event threads require an action and the action is to submit the output tool, we do that. And we obviously mark this as, hey, AI is in the state of calling some external tool. And in all the other cases, we simply just loop through the tools that, hey, these are the tools available for me. It could be perform web search and it could be others. Just to make sure that things are easy for us, I've kept it just for the one tool. And you can see the code that we have just for the one tool. But if you look at this, rest of the thing is just if statement. If the tool call function name is web search, we do this try catch. And if I fold this up, this is the piece of code. And similarly, there could be another if else statement that if we have a tool name called GitHub or a tool name called Figma, then we can do that kind of a thing. Once we are done with this tool calling, we simply break the inner loop and submit this all thing into this tool output. So whatever the tools, because your chat can actually call multiple tools in the single chat itself. It can call the web search, it can call CSV, calculations and whatnot and more. Now, if the thread is complete, we mark this as complete and that's it. We break the loop and go out of it. And if the thread fails, then we also handle this gracefully. And if the tool length is greater than 0, then only we simply say that, hey, there are some tools we have to submit and we have to get that. Otherwise, it's not. So as you can see, it looks like a lot, but technically it is not. We are just handling a few cases. And yes, there are more cases as well, but this is the orchestration that we are doing. So once this helper function is being designed, which is only for the OpenAI, now I have OpenAI agents. Now in the OpenAI agents, what we're doing is, again, the whole goal is to just the clean up and handle the things. In the OpenAI agents, the first thing is to get the user. Your user can be behind some Google authentication or a password-based authentication, or could be just a username. We get that. Once we have the user, we want to make sure that he understands that when did he last interacted, bring up all his chats and stuff like that. And this is the init method. Again, it's kind of orchestration method. And we have some of the tools here as well. Like we have the get writing assistant prompt. So in order to tool to run, the magic actually happens within the prompt itself. And then we simply handle the message, just like we handled it up there, that, hey, how we are going to write this, how we are going to do all of these things, send the events and all these things. This is all AI assistant API libraries that we have. It looks like a lot, but this is mostly copy pasted from the OpenAI itself. They actually give it all documentation mentioned nicely. And this is the only most complex part of this application. Once you have this, rest is just basic. So if I go ahead and click on the create agents, this is how we create the agent. Notice here, now it's the whole thing that is going on is the stream chat, the server client, OpenAI agents, and the types. That's it. So it's basically an interface that how we are going to interact with the agent, OpenAI agent that we have created. Notice here the chat client just gets connected. We simply watch this channel that, hey, what's happening on this? And based on this, we switch the platform. So user can switch between a writing assistant or just an OpenAI, and that's it. No code. So you can see that this is just 30 line, hardly 30 line doesn't make any complex code. All right, sometimes it does. So this is basically another orchestration that what the user wants to do. Maybe he wants to interact with our writing assistant. This could be one. There could be a social media assistant. There could be a CSV analyzer. And this is how you design a production grade agents that we have. Now, once we are done with this, then it's just an API calls. If you look at the index.js, this is something that I shouldn't be worried much. By the way, this is interesting. I'll walk you through. So this actually periodically checks that whether any AI agent is active or not. If it is agent is active and we are not using it, we just clean this up. Anyways, after this, this is the major thing. We are doing just the get request and post request and all of that. So notice here we are doing a post request to start the agent. So anytime you want to start the agent, you provide me a channel ID, a channel type, that this is a messaging channel, and you send me the data that what do you want to do. We are doing a simple validation for the channel and we simply try to just invoke our agent. So AI agent cache has, if it is already being done or is being working, then we handle that case. Otherwise, we simply go ahead and say, I want to invoke a fresh agent, a create agent, and let's initialize the agent. Then it takes care. Once we initialize the agent, the whole control goes to this file where we have this response, and this is where the whole things actually again goes up. So these are just after this point these are just the API calls. That's it. Similarly, if you want to stop the agent, we'll provide a stop button. It just basically dispose everything, dispose the client, free up the memory, free up the already running calls and all these things. We can also make a lot of pull requests onto this kind of a pub/sub model into the agent AI status that you can constantly look for all the events that are being streamed and can work with that. And yes, finally token as well. In this advanced tutorial, we shouldn't be worried much about the token. It's just JWT tokens that we kind of provide that we have. So server can create tokens. I didn't need to use the JWT even in this one because server client has the ability to provide the token for me. So this is it. This is it. This is the application. And I know it's a lot. That's why I said this is a complex tutorial, but this is the whole backend that we have. It's hardly like 5-6 files, but the complexity is really, and all the complexity is getting introduced because of the agents that we have. Hope this is fun. The front end part is actually rather comparatively easy. I would not call it as easiest of all, but relatively easy. So if you look at the package.json, what are the dependencies we have? We have hook resolvers. We are using React hook form, React form hook. So that is helping us. After that, a lot of Redux and components, which are all cooked up. So this is not something that we designed. It's all available to us. We have the classic React, some date pickers, hooks. Yeah, and we also are using some of the stream chat and stream chat React. Let me walk you through with some of the interesting stuff. So if you go on to the front end part, React actually, this Getstream gives you all the React UI components in the client. So if I look at this UI components, just look at this. You have all these rich media text and all these things are given to you. Let me go ahead and give you the chat. So you have these chat messages and all these controls available to you. Yes, you can on top of that layer your UI, but you don't have to do everything. The chat context is also available to you so that you don't have to write your own setup dedicated context. We have all the management for the thread list. We have for the message list. All of these UIs are actually available to you. And notice here how many depth of the things that you can do with this one. So we actually utilized a lot of this in this one, and that's why you see the UI. Then we have our classic Zod and UIDs and all of this, a lot of dev dependencies, and that's where it actually gets crazily good. Front end was not the focus of this entire video, but I just wanted to make sure that you understand the whole things and gist of it. We don't have much of the libraries. We have just the utils already pre-cooked for us, nothing much. We don't have too much of the provider, the theme provider, not much of an interesting one, the chat provider. Notice here how we are just dependent on mostly the stream chat, which gives us the user, and the stream chat React interface, which gives us the chat as well as use create chat client. So these are all hooks and interface given to us by them. We are not doing much of the stuff in this one. Really, really nice. I have written some of the comments for you, but this is the piece of code that we actually write. Yeah, it is actually that crazy good. And again, this is not the code that we are writing. This is all coming up from here. So notice here, when I mentioned the chat is available to you, this is exactly what we are using. It makes life so much easier. Otherwise, we probably would have to spend another 1 month or probably a little more to design this whole interface and stuff. And if you look at the components, very standard components to work with that. We don't have even login. We are just asking, hey, enter a username, and then we simply go ahead and submit that. That's it. Nothing much, nothing crazy that we have done in this one. Then we have this chat messages. Again, you will notice that we're not doing the heavy lifting part in itself. We are just managing the states, some of them, and then we are just calling the things that, hey, just go ahead and call this one. So again, a pretty crazy stuff if you ask me, that it's a lot of code that we have written. And you can also go through with this code, and I'm pretty sure this will help you. This is going to help you if you're building something similar in your application as well. Then you can go into authenticated app. We have chat provided. We have authenticated core as well. We can just go into this one, lot of stuff. And yes, it took us a lot of time to experiment with this. This was more of our own experiment. We wanted to see how complex things can go into this one. So I would call that, go ahead, check out this repository. If you have any question, just ping me up on Twitter or on LinkedIn. I would love to help you more because this is kind of an evolving project. We are also constantly working on it as a side project, as a learning journey, not as something that we want to build as a product or something. But just by looking at the products that we see on the market, which are seen as just, hey, this is a chat wrapper. No, it is not. It is one of the most complex application that you are going to see around. And that's all what I wanted to share in this one. The code repository will be available to you. And I hope you have got like 10 to 20% of the knowledge. This is like a pure production grade thing. I didn't wanted to make a tutorial which is like step by step, hey, go follow along with me, write code along with me, because the senior developers want this much of the KT, the knowledge transfer, and then they want to, or they prefer to go into the code base on their own, and that's what this exact tutorial is targeted for. That is it for this video. Let's go ahead and I'll see you in another such kind of a tutorial. I don't make this kind of a really complex and professional a tutorial targeted for the professional users very less. In the next video, I'll keep my focus more on the beginner side so that we can just talk more on the friendlier stuff. That is it for this video. Let's catch up in the next one.